Okay. I will try to share my screen right now.
Hello, Mr. German. Welcome to this session. Hello, everyone. We are happy to have you. The 3 more sessions will be with Mr. German, and we are welcoming him to our Python intermediate course. So we are just starting the class. Thank you very much, Mr. German, for joining.
Thank you for warm welcoming. I wanted to say that we will focus on this, on what we will focus on this 3 last sessions. First of all, I would like to share the screen. Let me know if you will see my okay. 1 second. Okay, never mind. So I will right now I'll tell you what we are going to do on these sessions. First of all, I would like to tell you that I will try to more interact with you, all of you guys, and I will check from time to time the chat for questions. We will take some pauses for Q&A sessions, short one. So don't hesitate to actually ask me, and or if you have some urgent question, for example, like about something that happens right now on the screen, feel free to unmute yourself and to ask it in a voice chat. But please don't do it to many people together at one time. Okay. So first of all, I would like to start with a plan of our work. So we will cover the computer vision, OpenCV, and a short introduction to neural networks. I will tell you about how color models works in Python and a specific library that's actually quite comfortable to use. And I will tell about the ideas that lay besides of the neural networks. Then we will talk about specific features of neural networks and specific approaches. It will not be like cutting-edge approach, but it will be more detailed. And second session, it will be about convolutional neural networks and object detection. So it's more focused on not on a color filtering, more it will be focused on processing of images. So right now it's 2 sessions, but I would say that these sessions can take quite much time. So I decided to split in 3 sessions. So we will cover as many as we can during the first session, and the leftovers during the second session, and the leftovers will left on my third session. And actually, also, I will have the assignments for you for each session. There will be 2 assignments. They're required for mandatory required to complete this course. So for each session, there's assigned material requires knowledge from actually our class. And you can do it just using these laptops. You will need to think about this one a bit, but it's not so hard. So even if you will not succeed to complete, please share. And I hope that we will get enough time on the third session for a Q&A about the assignments. You will get one, how much we can let Dr. Baktash, how much time can we let people for assignment? 1 or 2 weeks?
Actually, we have no problem for timing, so the course will be for 1 hour. We will let the students to join. There is no problem, but you can follow as much as is okay with you. There is no any issue because we have the subscription of the Meet, so there is no problem.
Okay, so if this call for students, so if you will get some issues, let me know. I will send for you assignment and submission form where you can assign a collab link. I guess since you already worked with Zorek, you already know you're not introduction Python course, so you already know that how does Google Cloud works, I suppose. So, but if you don't, also don't hesitate to ask. Then I will adjust and we'll do short introduction. Okay. So let's go. The first topic is OpenCV model, not model library, and we will talk about the general color representation in, not only in Python but in computers. So there's a lot of different color models like RGB, SMYK, and HSV. They are similar but a bit different. So RGB model is three numbers that contain amount of red color, or green color, and blue color. The second one model is contain cyan, magenta, and yellow color, and K is the black. So these combinations of color allow us to actually get any color that we need. So combining these together. So here you can see that we will combine the green with red one, we will get yellow with, for RGB model. For SMYK, that's actually the opposite. This is supposed to be white, actually, not black here. Sorry. For SMYK model. So the separate color is white, not black, because for the SMYK model, the combination of cyan, magenta, and yellow will give us a black color. And HSV model is more convenient to work with, actually, sometimes. You have the color wheel. The hue model determines where we are on the color wheel right now. So from the 0 to 180, for example, or from 0 to 100 to 360. And saturation determines the saturation of color. So how colorful are our color, and value determines amount of black of this color. So that's how bright is our color. This is RGB and HSV models are more frequently used in computer vision models because it's easier to handle them, but it's not the only one models that are used. The other models can be like YIQ model. There you have like representation of color as three-dimensional space. So you will get a point somewhere in this three-dimensional space. We will not use it. I just put it here just for your understanding that there's all these three color models doesn't represent all color models. So there can be exotic color models that can be used for image processing and visual data representation and processing. And we will start from image filtering using OpenCV library. Technically, you can do it not using this specific library. You can do it with a lot of types of library. But this is quite easy library to use. I have here link documentation for this specific library. You can read if you will have questions about specific functions, specific methods, or specific classes, but contains this library. You can refer to this link. So now we end up with the color modeling. I will check some questions. Do we have some? Not now, right? Guys. Going forward, image filtering by OpenCV. OpenCV is a quite famous library, as I said. We will start from the mounting our Google Drive storage, because I store my images for this class in the storage. It will be more comfortable to use this image. To use the images from Google Drive. And it also will be comfortable to do for you, because I put it here on purpose as an example. But I guess you already done it before. It will take some time, because right now it's connecting to Collab. Cloud. Is it? Okay. Yeah, the Google Cloud requests access to your Google Drive, so you should confirm it if you go on to use it. If you not going to use Google Drive and you run some code on Google Cloud, then, especially if it's not your own code, for your own safety, don't use it. And second row, we just installed OpenCV library. I should warn you, if you going to use a local environment, like your personal ID, or like Visual Code, or from Microsoft, or PyCharm, or some other IDs, the commands can slightly differ from those that I use in the Google Cloud, because the syntax bit different, not too much, but there is some specific details. So check documentation before you will start it. Again, documentation link here. Here is my initial image. So I installed library. I imported OpenCV for filtering, and imported PyPlot for representation of filtering that I going to show you. This is an initial image with a red circle, yellow rectangle, and green rectangle. So our task for now, visually, by our eye, we can easily determine where each of these objects are and what are the colors. But the thing is, if we are going to read image using OpenCV, for example, you see this method that allows us to use to read images. Here's the path for specific image, and there's a flag that you can actually flip image or mirror image. Here I put a flag that image unchanged. Here I used OpenCV to load image, but the thing is that I used PyPlot to draw image, and this is quite two different libraries. So you should be careful when you use those two. Why? 1 second. What happens? Oh, that's broken for now. Oh, sorry, that's not. I don't need this. Close it, please. So here you can see that I wanted to show you that there is two different actually color models used in OpenCV and PyPlot. But you can see that actually with the new update, it even became more complex to use these two libraries together. So right now, our image data type has object type, so it's object, and we cannot convert it in float. It can be actually done if we will check. Image shape, for example. No, we don't want to read. 1 second, I will check the data. This should be fine. I will check my link actually here. Sorry. Something is broad. Okay. Back. It doesn't read somehow. Okay, let's check it. Okay, never mind. So yeah, be careful when you work with two different libraries. So try to use visualization tools for library that you are using. If you are using PyPlot, so work with PLT images. Otherwise, you should convert images from objects to NumPy arrays. That's actually quite useful. Okay, we're going forward here. Yes, it's also notice that output methods have different visualization color spaces. As I said, next step is a filtering. So we loaded images or image already. Second, here we can try this. I don't want to know why. What happens? Let's copy path here. Okay, yeah, sorry. The path here was wrong. My bad. Yeah, here. You can see that initial image was with a red circle, but here when we use different libraries to represent, actually, we have switching of colors because these two different these two libraries use two different color models. Here, OpenCV library use BGR model. It's modification of RGB, not modification. They just switched two numbers. Here we can actually convert this BGR to HS3 to correct representation, but it's not HS3. We should convert to RGB. Actually, yeah. It will not work. Why it will not work? I'll tell you a bit later. Second. Sorry, I forgot it. No, it's, need to start from this, and this. Yep. Yeah, never mind. So PLT actually don't use FS3 color space by plot. I mean, OpenCV use BGR by default if you are not put any flags here. Here can be added several flags. And we can go forward. So we should remember what color of our initial image was. But to actually display initial image, we should convert this image back to from HSV. As you can see, I converted from BGR to HSV. I will tell in several minutes why I did done this. But for PyPlot, we need to convert HSV back to BGR and actually to RGB. So why HSV model is quite useful for filtering color model? I will tell you on this example. Because if we will have some combinations of colors, for example, it for us hard to determine not to determine, but to separate one color from another color. It can be done by just specific value of color. If this value higher than this number, we can say that this color is yellow. If yellow color value is more than 90% of max value, we can say that's yellow. Otherwise, it's not yellow color, for example. But what we should do in case if our image has some shadows or some reflections or something like this, the color of real object didn't change, but the saturation of color was changed and value of color was changed. That's why I say that we are going to use HSV model here, because it's extremely convenient to work with the colors that change their properties during the time. Because if you can choose any sector of this cylinder that you're going to filter, and you will get from dark cyan to light cyan, or even to almost white color, or almost to black color. Yeah, so you will get more flexibility with color filters. And we remember that 𝗖𝘂𝘂𝗵 model is a hue, saturation, and value. I put here specific filter. Saturation quite low, low filter is 50. Value, lowest value is also 50. So we try to actually extract some color that some feature that actually has specific value of color, but not specific value of tone of this color, not specific value of shadow. We try to capture almost all range of shadows and light shapes of this color. You can see the first value is the ash from 25 to 40. You can see on this scale that from 25 to 40 is a what color? Can see your messages in the chat. No one tells. It's a yellow color, right? Yep, it's a yellow color. You can see. So here is a quite wide range. Well, 35 actually also can work. So here on our initial image, we have yellow rectangle. So we can try to capture it. If we will run, you can see that, yes, we captured specific feature that we actually aimed to capture. So the lowest value will filter, so everything that belongs below these two separate sets of values will be filtered. Well, how it used is CV2 and range, the function, where you could put image object, lowest filter, highest filter. Don't forget that lowest goes first and highest goes second. And then you can use CVM show. But here, that's one of the actually difference between local OpenCV library and Google Cloud OpenCV library. It's actually here you got this function, but in local library you will get something like this. Small difference from local one, but it doesn't work in the Google Colab. Do it to the specific of the Google Colab. You also can build the mask using PLT, iPlot. Why? Because mask actually is a NumPy array. You can see it has shape, same size as image, and it doesn't has any color channels. So as you remember, I said that every image, I said that there's different color models, and depending on which color model are we using, we will have another channel here. You can see 3 channels. So this is a pixel width, height, and color channels. So we got an array or matrix, any type that you would like to call it here. So since this matrix is only 2-dimensional, so it doesn't have any specific channels, PyPlot can show it quite well. So we don't have here conflict of color models. Any questions on this part? Anyone? No? Okay. I will go faster then. For finding contours, here in OpenCV, there is a function, find contours. In documentation for find contours, I specifically was separated from the all other documentation because it's, yeah, we will work with this specific part. It will find the white objects on mask. So filtered objects. White, I mean this here value is 225 and all black values is 0 here. So that's why it represents. And the second argument of this find contours function is what contours it will be. It will be external contours or internal contours. Because we can try to find contours inside of the white shape or outside. So we will try to find outside. That's why I put here external flag. And chain approx none. It means approximation. You can check again documentation here that there is several specific approach to approximate the contours because sometimes you don't have perfect image. You have like some tiny dots or different colors inside of the contour, so approximation could help you. But we will actually do approximation here too, but without this specific CV function, CV flag. You can check. There's specifically, I don't remember right now how many, but there is a specific approximation mechanisms in CV OpenCV library. Go on further. You see, I didn't find contours. I will try to find contours, and I will color them. I will put specific colors for these contours. I will draw it on our image. What I will draw, and this specific value is determine that our contours, all of our contours that we found will be drawn, because here I didn't talk, but you will get a list of contours. Here on this image we have only one filtered object, but sometimes you have a lot of them. So you will get this function will return a lot of contours, a whole list of contours. Following further, and the thickness of the line of drawn contours. Let's put it 10, for example. We can see here the yellow BGR model. So blue plus green, we got yellow color, and we can see that here our contour. It's quite thick, 10 pixels thick. But you remember that our image is an object of OpenCV. That's why here we can see it only in this way. We cannot see correct colors here, except the contours, unfortunately. And we can generate a new image from this one to save filtered object, our contour. We can convert it to RGB from HSV because we can previously convert it to HSV, and we can see here our contour, as you can see, black. Why it is black? Since I put here a yellow. Can somebody answer to me? If no one will answer, I will try to ask randomly someone. Any ideas? Why it happens here? I put here yellow. We can see it yellow on pyplot, but here it is black. Let's start from the first person. Amam, sorry. Do you have any ideas? You can turn on your micro. Okay. Looks like Mr. Or Miss Sam, I don't know, is not here right now. Just in case, sorry for my pronunciation. If I will misspell your name, please correct me. Let's do 𝗜𝗁𝗶𝗁𝗶𝗁𝗶. Can you tell us? You can type in the chat if you have any ideas. You don't need to talk if you don't want. Okay, Mr. and Mrs. Ramal. Okay, anyone, can you please check that your micro is working? Can anyone check it? Maybe they are just not working. Please message in the chat then, here. Dr. Bakhtash, do you hear me?
Yes, yes, we are hearing.
Yeah, well, I have
that who want
concern.
to? Yeah. Unfortunately, no one is.
Don't want to type anything, please, folks.
Yeah, Mr. 𝗤𝗁𝗶𝗁𝗶𝗁𝗶, Mr. Babar, Mr. 𝗼𝘆𝘁𝗵𝗁𝗶, you hearing our voice, yeah?
I should do it in the beginning, yes. I'm sorry. Yeah. I saw that someone marked the emojis here. I suppose that everyone is listening. No, someone please message in the chat. Otherwise, it will be just wasting of your and my time. If you don't listen, please just tell me about this one. You can use your micro or you can use your chat. Here's the chat. You can see it. I will stop translation for a while. Anyone?
متاسفانه چرا سهم نمیگیرن بچه ها؟ آقای رضا نظری، رحیمی صاحب، فیروزه مظفر، لطفا سهم بگیرن در درس ها. سوال داره از شما. Please, we are waiting.
Okay. Otherwise, I will just continue the lecture because I see there's note maker here. The AI note maker. I hope that it will be useful for at least someone who will listen and watch recording. I know that there is a lot of constraints can be for you that you are not able to talk, but at least type some. I guess it's possible during the lecture when you reach the time. Okay, following forward. Here, since we obtained the contours, we actually can get from these contours the x and y coordinates, for example, of our contours, and we can find here this is not XY coordinates of contour itself, it's coordinates of its center. And as you can see, I used the method that allows us to function of library that allows us to draw circle in specific coordinates here that I've obtained here. There's moments that can be read from each of contours. Please be careful because the function here that founds contours, this find contours function, return list of contours. That's why I decided to use the first element of this list. The radius, the color, and the size of the border of this circle. So if
Sorry,
I will
Mr.
do this,
can you please share the screen? Sorry.
sorry. Yeah, I stopped. I didn't. So 1 second. Yep. Now we can see.
Yes.
Thank you. So yeah, here's the contours. You see, as I said, it's the first element of our list of contours. Since it were lists. So I draw a circle using the circle function of OpenCV library. The second argument is coordinates. The third argument is the radius of this contour. And the fourth argument is the color of this contour. I put here some color. You will see it right now. Actually, it's especially black color. And the thickness of the border. And I got this one image. I got here the black contour, and for this now we finished the finding centers of the contours. So you are able right now to find specific object color, colorful object, and separate it from the other objects. So sometimes it's not convenient, especially if you need some specific yellow object, or not exactly yellow, but we will talk later about this one. On the next session, I will tell you about how to filter different objects, not using OpenCV, but using the neural networks, how to do it. And going backward to why here I put yellow color and we finally got one black. It's because here I represented it in RGB model, but before I represented it to RGB model, I worked with object of OpenCV, and OpenCV object has HSV model right now. So in HSV model right now, this value of color, here is the red color, as far as I remember. No, sorry, yeah, here actually from 0 to 180, but in this case, actually, we can put it back and nothing will change. It's a bit adjusted. VGR model. So this, sorry, 1 second. So you draw a circle in VGR model. Just to remind you, RGB model. Oh, sorry, in RGB model, not in BGR. We put it in a BGR, but we present it in RGB model. My bad. And we forgot when I asked you, I didn't emphasize this information, but we converted FSV model to RGB. So this color was converted as HSV color. So, and since it's HSV, we don't care what color it is actually, because right here we have 255, so it's a max value, and yeah, sorry, the lowest value, the last saturation. Sorry, saturation maximum value of saturation, and value itself, value of value. Sorry for repeating myself, is 0. Since is 0, we don't care much about this number. The brightness of our picture, of this specific contour, will be 0. It means that it will be black. That's why it converts to be black. And as you can see, since I already found center of the contour and draw it, it actually, when I started this cell, it also draw us again the contour, but also drew a small circle inside. Yep. And we going forward, we will try to filter what happens. 1 second. Wrong. Again, wrong number here, sorry. Again, we loaded our image. Again, we try to convert it to FSV. We can see it here. And we can try to filter all 3 colorful objects. So it means that saturation and value shouldn't be 0. It's below 0. And we will cover all of the color wheel. So since we covered all color wheels, all value of color wheel, we will get all 3 features. We filtered just a background in this case. And for each contour, we can draw a circle. So we will, if we will find some contours, we will go in a cycle to get to calculate some contour area, because sometimes we can find extremely small contours that can be actually artifacts of images. So in this case, we should calculate area. You can do it by yourself manually, but also you can do it using a contour area that included in OpenCV. I used contour area. So if it's less than 300 pixels, square pixels, then we can just continue and skip this contour. Otherwise, we can continue. What does convex hull means? Sometimes you will get contours that partly damage or partly has artificial parts. So this will try to approximate, but not. It will not simplify a feature, but it will complete the shape. And here I decided to use approximation function on our whole contour. This is the length of approximation. You can vary it. Depending on this number, you will get simple or more complex feature. You can approximate it in 4 points, for example, or something like this. Depends on what features are you using. And if our approximation exactly equals 4, it means that we found a square or rectangle. Means something with a lot of angles. We can draw contours here. I put here that this draw contour is a black. If we will find rectangle, but if we will find our circle, I put another color. It's almost white. Yep. And so no, it's not white. It's 80. Sorry, don't remember. 80 is cyan color. So we can do it here. And if we will run it, okay, can see it here. Interesting. Looks like approximations our case here didn't work well. Maybe because I put too much value here. Or too less value. RGB mask. Yes. Yes. Indeed. Let's do it long. We have 3 contours, it's okay, but don't want to draw us. Don't want to recognize actually this rectangle. Maybe something wrong with approximation. Yeah, I've made a mistake in approximation constant. So you should adjust approximation constant. Or usually I do it from time to time, depending on a task manually. But you can also find in internet, for example, if you will have access, you can check the approximation length here, the parameter adjust. Usually it's not, it shouldn't be big value, because otherwise you will not get correct approximation. So for example, if I will put here 1, sorry, I will start it again. Yeah, I put here 1, and everything, every contour is cyan. It means that every approximation, our approximation wasn't correct in every our contour. The number of points was more than 4. So approximated figure was had a lot of points, and it doesn't work well. But if I will put too low value, the number of points will be even less, and will be less than in correct case. And if it's less, then we will get again extremely strange situation. So yeah, I forgot to tell that usually it's the length of approximation depends on length of the contour that you are going to approximate. So if your contour long enough, you should just multiply it on specific constant. You don't need to adjust. You don't need to adjust every time that you found the contour. You need to adjust for specific conditions that you are working with. Yeah, here you can see that our approximation didn't work well, and our rectangle to rectangular was approximated more than with 4 points. We can do another condition here actually. Sorry, we can put here 3 points, for example, to recognize them. to separate this all. Didn't work well. Yep. Okay, never mind then. Approximation for each never mind. Yeah, in this case, yeah, you should adjust this number depending on the task you're working with. Yeah. There is a lot of other functions on OpenCV. You can check it. I will skip it. How much time did we left? Not much, right? Okay. I guess on the next, we will leave on the next session. That will start to work with neural networks. It's an introduction into neural network. I will introduce a few. I will introduce it right now, but we'll work with one specific framework that it's easier to start to work with, but it also has a lot of functionality inside, so it can be adjusted since you will get some progress in machine learning and neural networks. You can switch to other framework if it's more comfortable for you, or your project is working with this framework, or you can keep reading the documents and find what can be done in this framework and cannot be in other. So definitely, I would say that there is not a big difference between them. Keras framework is a high-level framework, so it makes developing of models quite easy. But at the same time, if you want to do some tiny adjustments or deep-level, low-level adjustments, it's harder to do. So keep an eye on it. We will work with Keras. There's a lot of other TensorFlow, like for example, extremely popular PyTorch framework. JAX, not so popular, is my opinion. And also, I put here a specific resource that you can check. That had a lot of information about machine learning, data science, object detection, about everything that I talked about today. It's a Hugging Face. It's open access, no, as far as I remember, even no registration required, but you also can register in Hugging Face to read the articles that after the have there. So this resource is focused mainly on machine learning and deep learning studies. You can also do competition in Kaggle. That's also possible. Okay, and this is all, I guess, for now, because I'm already out of time a bit. So yeah, and we will talk about functions, neural networks, how do neural network works, and so on next time. Okay. Thank you for listening. Do you have any questions?
And I don't know why today the students didn't respond to the questions that you had. So I hope for the next session they can have their how to say cooperation in this regard. And the problem in Afghanistan nowadays, it is due to the electricity and internet. So many of our students are facing this challenge. I hope for the next session they can join, and we will let them know like one day earlier that we will have 2 more sessions with you. So thank you very much for today's session. Thank you.
Thank you. Well, I know, hope so. If they will struggling with assignments, so they will not, at least there, they will not hesitate to reach me out, because yeah, internet disconnection sometimes happens, but to send an email can be done in
yeah, definitely.
time where you have it, right? So I will try to answer all of your emails. If I will get a lot of them, I will not promise that I will answer everything quickly. So please forgive me in advance. So, but by the way, I will try to do my best. Thank you very much. Yes, I hope that next time we will get more communication interaction, because it's much more effective to have interaction when students as students will answer a question during the lecture. It extremely will help you to understand the material.
Definitely.
And yeah, and to ask is also important thing on the lectures. So even if you will not do it on this lecture, try to do it in some other lecture. It will be interesting reaction. Thank you.
Thank you. Thank you so much, Mr. Suslin. Thank you.